Chapter 5, Section 7 in the 7th grade textbook is entitled Slope-Intercept Form. So here we go. As I promised in the last presentation, now that we know what slope is about, now we're going to be able to graph a line once we have it in this form called slope-intercept form. The whole perk to slope-intercept form is no calculations. When you've seen me do the table method in the last few sections, you had to do a bunch of calculations. All of a sudden, no calculations. But, again, the catch is you've got to get it in this special form called slope-intercept form. That's what they're going to do here. So what is the x-intercept? That's the x-coordinate of the point where a line intersects the x-axis. The x-coordinate of the point where a line intersects the x-axis. So simply put, that's where our line goes across the x-axis at. Y-intercept, that's the y-coordinate of the point where a line intersects the y-axis. So again, simply put, it's where the graph goes across the y-axis. Slope-intercept form, a linear equation written in the form y equals mx plus b. Again, from the top, x-intercept, that's the x-coordinate of the point where a line intersects the x-axis. Y-intercept is the y-coordinate of the point where a line intersects the y-axis. And slope-intercept form is a linear equation written in the form y equals mx plus b. So, let's look at this one here. Now, in this one, they're only talking about the intercepts, which is really easy. When they're asking me to find the x and the y-intercept, what I mean is, tell me where it goes across the x-axis, tell me where the graph goes across the y-axis. Well, if we take a look at the line that's on the screen there, it goes across the x-axis right here at 2. So that's why they're saying here the x-intercept is 2. Now, if you want to write that as a point, that would be the point 2, 0. Remember, 2, 0, it's always written x, y, so the 2 represents where it is on the x-axis, over here, 2. And the 0 represents where it is on the y-axis. Well, 0 on the y-axis means I never moved up or down. And indeed, to get over to this point, I would have never moved up or down. All right, y-intercept. Y-intercept is simply where it goes across the y-axis. Well, it goes across the y-axis right there at -4. So the y-intercept is -4. All right, so I want you to tell me now, what is the y-intercept coordinates? Well, the x-coordinate is 0 because we never have to move right or left to get to this point. Anything on that line, that's a true statement about. And then the y point here is -4 because on the y-axis I'm here at -4. Again, what's really important here, x-intercept is 2, y-intercept is -4. Goes across the x-axis at 2, goes across the y-axis at -4. Real simple. That's all you're doing. Tell me where it goes across the x, where it goes across the y. Same thing here for this one. So take a look at the x-axis first. Goes across the x-axis out here at 4. So that's why they're saying the x-intercept is 4. Write it as a point. That's 4, 0. Y-intercept, where it goes across the y-axis, well, that's right here at 1. Remember, it's just a standard number line, 1, 2, 3, 4, 5. All right, so the y-intercept is 1. If we write that as a point, that's 0, 1. All right, let's go on now. Now, here's where we're going to start talking about this slope-intercept form, this magic form that doesn't require any calculation. There's really no magic about it. It's very simple. All right, slope-intercept form, as it said in the definitions there, is given to us in the form y equals mx plus b. Now, no matter what form of an equation I give you, and I can tell you there's a few. There's this one called point slope, and there's this one called standard form, and then there's what you see here called slope-intercept. No matter which form we're talking about, x and y are always just going to say x and y. So those guys, in the end, when I'm done, when I'm writing an answer, all right, are always going to say x and y. The two things that are going to pop up as numbers here are m and b. Well, you have to understand what m and b are, otherwise you're not going to have a clue on how to graph this. M represents the slope. Well, that's good for us because we already know what slope is all about. We've been talking about slope for a while now here. Slope is rise compared to run, a ratio that compares rise and run. So, for instance, if I said to you the slope was 3/2, that means that whatever line I'm about to graph here is going to rise 3 and run 2. And you can do that comparison between any 2 points. B B is something a little bit different. B is what we call the y-intercept, which is a term we defined earlier. The y-intercept is simply where the graph of my line goes across the y-axis at. And in this case, since this number at the end here is 1, that means the y-intercept here is going to be 1. So this B number here is going to be 1. So let's take a look now that we have some understanding of what the little components are here. Let's look at our equation in 2a here. Y equals a third x plus 1. Well, that's the first thing they're going to do is they're going to identify. Slope, again, is this guy in front of the x right after the equal sign. Again, I'm saying that assuming that it's written the correct way. Indeed, this is written in correct slope-intercept form. If it doesn't look like this, don't try and do this because you'll get it wrong. But if it looks like this, you're good to go. So the number after the equal sign in front of the x here is a third. That means my slope is a third. My y-intercept is this what it says out here at the end. All right, in this case, it says plus 1, so my y-intercept is positive 1. All right, so here's what you're going to do. Step 2 is going to start this off here. It's going to tell us to plot 0, 1. In other words, what they're saying here is to plot the y-intercept first. All right, you're going to put a dot wherever the graph goes across the y-axis at. And again, since this number out here says positive 1, that means the graph is going to go across the y-axis at 1. Then what you're going to do is you're going to use the slope to plot at least one more point on the line. Now my slope here is 1/3. So a slope of 1/3 means I'm going to rise 1 and run 3. How exactly do I do that? From this y-intercept point I plotted, I'm going to rise 1 and run 3 and put another dot. Once I draw my 2 dots, that's all I need because a line is established simply with 2 dots. Connect my dots and you have a line, which is what they're saying to you in step number 4. So let's go ahead and take a look at that because that's certainly what you're going to see on the next slide here. All right. First thing we did is we plotted the point, the y-intercept point, which was 1. So on the y-axis here, we put a dot at 1, which is what you can see right here. This dot in green, again, right on the y-axis. First point in slope-intercept form is always got to be somewhere on the y-axis because it is the y-intercept. Then the slope here. The slope here was 1/3. That means I'm going to rise 1 and run 3. So from this point, rise 1, which means go up 1, and then run 3. Go to the right 3. Put your other point there, connect your 2 points, and there's the graph of your line. Sometimes the mistake people make when they do slope, for whatever reason, is they start back here at the origin and they decide to go up 1 and right 3. That's incorrect. You always start at the first point you've already made, and from there, that's where you take on your slope. So from here, I went up 1 and right 3, and that's how I got to this point. And that's it. No calculations required. I didn't have to figure out a bunch of x's in my head and then figure out what the y's are that matched up. I plotted my y-intercept, I plotted my slope, game over. All right, so let's take a look at this one here. Now it's asking me to write the equation of the line in slope-intercept form. So let me go ahead and write that general form up there for you one more time. Same one you just saw in the last example, y equals mx plus b. Again, the two things that are going to change into numbers are going to be the m and the b. M represents the slope, and b represents the y-intercept. Again, no matter what form we're talking about, x and y are always going to be x and y. All right, so do this in the exact same order we did the last question. If you remember, the first thing we did in the last question is we identified the y-intercept, where the graph crosses over the y-axis. Well, the graph crosses over the y-axis right here. All right, and on this number line, that's at -4. So my b value, my y-intercept there, is going to change into -4, which is what you can see they wrote down here in the solution line at the bottom of the presentation. All right, now I want to go ahead and find my slope. Well, we already know this point. In order to find my slope, I need to find another point. Any point, it doesn't matter what point, all right, as long as it's a point that's on the line and preferably one that goes through a set of grid markers. I see this point right here going through that set of grid markers, so I'm going to use this point right there. So to go from this point to this point, I see I'm going to have to rise a negative amount, which really means I'm going down. So to go from this point to find my slope, I'm going to go down 2 units. So my rise here is going to be -2. Then I want to find my run, because remember, slope is rise over run. How much we move this way, and then how much we move that way. Remember, when we do slope, we're always going to go left to right, just like we read a paper or a book. So once I've gotten here, now I have to go 1, 2, 3, 4 jumps to the right to get to this point. So my run is 4. So my slope here is negative 2 over 4. Now you might be looking at this and saying, well, wait a minute, that's a little bit of a different answer. Yeah, it is a little bit of a different answer because I haven't reduced this fraction yet. If I reduce the fraction negative 2 over 4, what does it reduce to? It reduces to negative 1/2, which is exactly what you see on the presentation here. That's m in the equation. So now what I'm going to do is I'm going to go ahead and change m into my slope, which is negative 1/2. So I've got y equals negative 1/2 x plus negative 4. Done deal. Again, I changed m into my slope. I changed b into my y-intercept. X and y, I always say x and y. End of the discussion. All right, here's number 4, word problem. It says a spider descends a 20-foot drain pipe at a rate of 2 feet per minute. The linear equation y equals negative 2x plus 20 represents the distance y the spider has left to descend after x minutes. Graph the equation and then identify the x and the y-intercepts and describe their meaning. Okay, so obviously it's a story problem, but it's about slope-intercept form because it's in the section about slope-intercept form. Here's our equation in slope-intercept form, so that's what I'm going to end up graphing. Now after I graph it, I'm then supposed to tell you what the x and the y-intercept mean. So once we graph it, we'll have to take a look at those points. As far as graphing it, that's what they're describing right here. Remember, we want to start off with this y-intercept number, which is this number at the end. Again, when it's written the correct way, and that is, again, it's got to say y equals something x plus a lonesome number at the end. That's exactly what this says. Right, so my y-intercept number here is 20. Right, so that's where the graph is going to go over the y-axis. So we could start having a discussion about that in a second. Slope here is negative 2, but remember, slope is always going to be written as a fraction because remember, what is slope? Slope is rise over the run. So I've got to treat that like a fraction. Negative 2 over 1. That's what they've written right there. So let's talk about graphing this guy. All right, y equals negative 2x plus 20. Well, that again means my y-intercept point here is 20. So I put a dot right here at 20. And then my slope here was negative 2 over 1. So that means I'm going to rise negative 2 units, which really means I'm going to go down 2 units. And then my run here is 1, which means I'm going to go to the right 1 unit. All right, now notice here, why you might be a little bit confused, but I'll straighten it out, is that this set of grid lines here is going by 2s. All right, so when I say I'm going to go down 2, I'm actually going down 1 jump, because to go from 20 to 18 is really me going down 2. And then I go right 1, that line is going by 1s, so that's good. So this is where I would put my first point. Well, again, it only takes 2 points to draw a line. So with this one I have here at the 20, and this point right here, I could connect my points and have my line. Now, sometimes maybe that might not be enough. Sometimes maybe you're looking for a little bit of precision, especially when you have a ruler. One thing we haven't really talked about a lot with slope, but it's something you can do, is you can repeat that slope over and over and over and over again as many times as necessary. So you could keep going down 2 and right 1, and down 2 and right 1, and down 2 and right 1, and draw a dot at each point in the way to have more points on the line. It might be helpful if you're looking for some level of precision. Well, as I keep going down 2 and right 1 here, what I see is as I keep doing that process, I do end up finding my x-intercept, which is kind of nice because that's one of the questions they asked me. The x-intercept is 10 here. This line is going through the x-axis at the point 10. All right, so let's come over here now and talk about what the x and the y-intercept mean. The x-intercept is 10. Well, as you can see based on the labeling of the graph and what they described to us a minute ago, 10 on the x-axis is an amount of time. Well, what amount of time does it represent? Well, if we read over to the left, it's at 0 on the distance scale. So that means when the spider has gotten all the way down to the bottom of the drain pipe, he spent 10 minutes doing that, which is what they're talking about right here. When we talk about the y-intercept being 20, well, what happens at 20 over here? Well, as you can see, that's when the time is marked at 0. So that means that's the length in feet of the drain pipe, just like we read in the question. The question started off and said it was a 20-foot drain pipe. The y-intercept is 20. There's a good chance those numbers are related since they're the same. They are related. That's exactly what 20 represents in the y-intercept, the length of the drain pipe. All right, so let's go ahead and continue on here. All right, last one here, they're asking me to find the x and the y-intercepts of the graph you see on the screen. Now, the y-intercept is probably the one that's easiest to do here. Where does this graph go across the y-axis? Well, it goes across the y-axis right here at 2. So my y-intercept is 2, which is what you can see I've written right here. X-intercept, where the graph goes across the x-axis. Now, that one is not quite as clean as it's been in other questions here. All right, it's halfway between 0 and 1. So that means the x-intercept, this point right here, is actually 1/2, right? Which is exactly what you can see as I wrote as the answer right there. How do we write that as a point? Well, that's going to be 1/2, comma 0. Remember, it's always x first and then y. X is a half, but y is 0 because we didn't go up or down. All right, so x-intercept here is a half. It's not a fluke. It can be those things. Sometimes it's just very hard to tell what those things are, so we try and avoid those situations as much as we can. Unfortunately here, we were thrust into it just on what the problem was, but we have to take a look here and say it's halfway between 0 and 1. That means it's 1/2. Y-intercept was clear. It goes right through 2. The y-intercept is 2. If you want to write it as 0, comma 2. And that's really all there is here. Tell me where it goes across the x-axis, where it goes across the y-axis. Those are the x and the y-intercepts.